graph is a mathematical structure, which is widely used to represent many different types of data such as transportation network, social relationship, etc. In the past decades, many graph drawing techniques have been proposed for visualizing graph in a way that structural characteristic in the graph is observable. However, it remains a challenging task because most of existing methods only focus on a single aesthetic aspect of graph layout. In this work, we propose a deep learning framework, DeepGD, which can learn to draw arbitrary graphs by considering different aesthetic aspects simultaneously. DeepGD is an AI agent that works just like our brain. Humans master a technique by repeatedly practicing until we reach a goal we set for ourselves. So does DeepGD. Human can specify a goal consisting of multiple aesthetic aspects for DeepGD. Then, it will practice to draw graphs over and over again to get closer to that goal, until it finally becomes an expert in graph drawing. So, how does DeepGD actually practice drawing graphs? First, DeepGD perceives the topology information from adjacency matrix of a given graph. Then, it uses its internal logic encoded by its parameters to generate a layout of the graph. For each generated layout, DeepGD will evaluate its aesthetic quality and adjusts its internal logic to learn how to perform better next time. For example, if the user prefers graph layout with uniform edge length and less node clustering, these two aesthetic aspects will be served as a guidance for DeepGD to learn drawing graphs. After millions times of practicing on tens of thousands of graphs, DeepGD becomes an expert in drawing arbitrary graphs. Let's take a closer look at what's inside DeepGD. The underlying backbone of DeepGD is a graph neural network which consists of a sequence of graph convolutional layers. For each layer, each node in the graph aggregates latent information from its neighbors. After a series of information aggregation, each node will collect sufficient information that encodes both the local and the global topological structure of the graph. Given these information, DeepGD is allowed to compute the position for each node in the generated layout. In summary, DeepGD leverages the power and the flexibility of graph neural network to draw graphs in a way that multiple aesthetic goals specified by the user are satisfied.